So the blue board that we were talking about is, you can see how they can coat it with a render these days, or we can apply that very, very flexible render onto the foam board and other materials. So what it means now is that where previously we would have built houses out of masonry or out of brick or block with a structural strength to put a render coating over, these days we don't need to do any of that. We can pretty well apply any type of internal substrate which sits between the frame and the outside, and then clad over the top of that with a render or some other material. And the great thing is that it's given us flexibility. Now, this is a house that's just been built around the corner from where I am. So this house is 3 stories high. The ground floor is almost all exclusively that renderable brick that we saw earlier. So it's brick construction down on the ground floor. You can see some of the bricks just tucked in. But beyond that, the next 2 levels above in that building is all polystyrene. The main benefit of the polystyrene, of course, is it's lightweight. They're large sheets that are easy to fit to the outside of the building. When they render over the top of that, you would not be able to tell the difference between brick and block work and render and the foam board. So you don't know where the brick finishes and the foam starts. So looking at the building from the outside, you would just look at it and go, wow, massive big 3-story building. But that 3-story building, 2 floors of that is lightweight construction. And the reason it's lightweight construction is because earlier when we were together the first time, I showed you examples of piles put in the ground. One of the pile sections I showed you were those large timber poles that had been hammered down into the ground. Do you remember that pictures? The big machine that hammered them in? That was about 3 doors down. So the land here is at best H2, at worst E, maybe P. So that doesn't mean that you can't build a substantial building. You just have to go about thinking the process through, that if a heavy structure like a big 3-story building is going to be sitting on the site, then you've got to make it as light as possible. So while they have a concrete base, the area above that can be lightweight. So here's another version of that. And you can also see that it creates some architectural flair. Notice here some of our roofing profile that we saw earlier. This is being shown out here over the top of an outdoor area. There's our green board or foam board sitting in here. This green material is the waterproofing layer that they put through just to protect it as well. You can see the big red washers that are used to hold it, and you can also note the strips. So in that you can see vertical strips that we just saw on that video, which is part of the way they bond the render onto that material. The scaffolding around the outside is all part of that edge protection and also for the workers so they're not hanging over the sides. We also note one of the things they showed in that video, around any of the corners you'll notice that there's a smooth edge. So it's effectively a piece of plastic that's designed to come round on a 90 degree and creates a sharp plastic edge so that any render sits up to that but not around the edge. So if we have any render around the edge, what could happen is it could easily just chip away and you end up with a rough edge. And so that's all around the perimeter of that as well. And the thing is too, with lightweight construction, you can cantilever. You can extend the top floors out further past the lower floors because it's only holding this is again, not in contact with the ground. With bricks, you need to have a solid base. You need to either have a concrete base or you need to have a great big steel beam to carry the weight of bricks up. This material is very lightweight foam. It's bonded onto the frame. It doesn't need to be in contact with the ground, and therefore you can extend it out past the lower levels. Here's that same sort of view again of that edging. So this is around part of the building. So we've got the main brickwork here, brickwork finishes. Then there'll be some sort of sheeting material go in there as a bit of a differentiation of architecture, and then it extends out with the roofing. This is the material that they were talking about. So that's the rock coat that they were going to be using. And this material it's a flexible render, but also you can color it. So rather than have to apply the render and then come back and paint it, you can pre-color the render and then apply the pre-colored render directly onto the building. This is also where we use infill material. So here's an example over a window. So instead of trying to have to put a steel bar in here and then put 2 layers of bricks in, it's simpler just to put a piece of board in. It takes away a lot of the time and cost. This is your more typical sort of cement render, so solid render. And what you see there is that these are the common bricks. Notice how rough the common bricks are? There's lots of pits in them. And that's all because what you're trying to do is you're trying to create lots of surface area for the render to sit into and help bind it onto the brickwork. Again, there's the smooth edge coming down that side. And that would be in pretty much every house that there is on the Gold Coast, because we use it internally as much as externally for render. But when we're building houses, it'll often find that sort of thing being used internally, where we have our plasterboard sheeting, where we join our sheets, and also where we do our tiling, where we might have a wall tile and a floor tile coming together. Maybe they might be there, or a wall tile comes up and changes direction, so we might over around a bath, say, might come up, come across. That edge you don't want to be sharp because people climbing it out without any clothes on. You might cut yourself, so the smooth edge is used on those edges as well. And there's a couple of different ways that it can be applied. One way is to just trowel it on, which is the old method. You used to be able to pre-mix all your render up, because this is a cement render now. It's more of a solid type. Apply it, and this one's being done as we go along. So I took photos of this. The gentlemen were working around the other side. They always start on the cool side of the house. So if the sun's on the front of the house, they'll start on the back. And then when the sun gets to the back, they'll be at the front. This is the alternate version. These 2 lads standing up here. This is a little bit different. What they do here is they've got a pump. They mix the render up. They drop it into a pump. The pump then pumps it out, and they just run it up the wall and through a pump, through a little nozzle. And once they get up the top, they then come back with a smooth edge and they just screed off or remove all the excess and get it nice and flat. There's some examples of different types of cladding, stone cladding and things that could be applied. We don't often see this style. These were the traditional builds where you get real brick construction made out of stone and block around the area. What is exterior wall linings? Well, they're there to protect the building from weather. Okay, they're there for a visual effect. And they preserve the structure. They preserve the frame of the building. We've seen masonry as one example. Let's have a look at timber as a cladding. A number of years ago, this material, which is called Western red cedar, was used extensively. When I first started in the industry, I was working for a building company. That company was sort of where I did my first sort of apprenticeship of building. They used a considerable amount of Western red cedar on their buildings because they were a building company that wanted to differentiate from the rest. Most builders were building concrete floor, brick construction, and they went for the market where land is not flat. They were working on non-flat sites. So when every other builder went, oh, it's too hard, we can't build on the site, people would then come to us and we go, yep, we've got a whole multitude of designs. We had split levels, 2-story splits, so we had like a full-size house on one level and only half the house on the lower level, taking advantage of the slope, cutting in. We had a multitude of different designs that were independent of the ground. And Western red cedar in the time was the popular option to use, but Western red cedar is a native hardwood. It takes hundreds of years to get big enough to be able to get a large enough tree to make use of. So we've gone away from that again. So now again, modern practice is going to these manufactured materials. This is the sort of houses we were building. So this is the company's style that we were working on. This was split levels, actually 3 levels. So it started out at a midpoint here. It would go, you go up some stairs to a higher level, and then you go downstairs to a lower level. Here's another one that's just a local house, and it was just built with timber as an alternative to brick. The house next door is brick veneer, so it's not like it's any unusual location. But this particular design, which was back to the colonial style of construction, more in tune with the use of natural timbers and things, was incorporated what they called chamfer boards or timber boards down the outside of the building. Okay. Now again, for the assignment, you've probably read the assignment brief for the assignment 2. You'll notice that some groups will be working on brick veneer cladding and other groups will be working on timber cladding. So what you're looking at is this style of construction where you're going to be applying timber over or onto the frame of the building rather than putting a brick veneer skin up the building. So those doing brick, well, you've seen the slides for that. Those doing timber, you're looking at this section and looking at putting sheeting over the top of the frame. Here's some other examples. Another one, steep driveways. Notice these all often relate to steep sites because we don't have flat land. And that doesn't mean you can't build on a slopey block. I made my first 2 years of my money working for an industry in a building game that didn't want to deal with flat blocks. Yet the whole industry keeps pushing people towards flat block construction. And I generally believe there's a much better way to do it. I love this style of building because you've got space under the house. You've got big verandas and decks you can look out on and sit up top. Look at how high that house sits and gives you like a presence, sense of being. That adds more value to your property being up off the road. Storage, putting cars in, put lawnmowers in, put your garden shed, tools, and any of your toys and hobbies. You might have a trailer or push bikes and all those things. You can put all that underneath the house. Okay, these are more sort of eco-orientated. So we're getting from one extreme to the other. We're now going right into light contact with the ground. So this type of construction, what they've used is plywood sheeting. So marine ply is what they use to build ships and boats with. It's very high and waterproof. And by applying it onto a building, you can then stain it into a specific colour. Plus you can also put this, they've just put timber stripping over the top of that to create a point of difference. So it's not just a flat board, it's a rather nice architectural look. Why is this particular style so well suited? Again, lightweight construction, sitting on a timber frame, lightweight roofing. Look underneath the building, you'll notice there's no land. The building, there's nothing below that building. It's sitting up on poles. So there is no real ability for that structure to be in contact with the ground. So therefore the cladding that suits that building best reflects something that is going to be self-supporting, attached to the main frame of the structure. So why is there benefits? Well, plywood can be bent to shape, so you can put different thicknesses in. It's very good acoustics as well. Timber's good from acoustics point of view, but also too it's very good from a temperature perspective too. Timber doesn't build temperature up as quickly as say masonry, and masonry will hold temperature for a long period. So it might take a while for the brick on your building to heat up, but once it's hot, it's going to take a long time to cool down again. Timber doesn't have that much of a variation. Great from that point of view. And to me, again, it's a good product to use. I'd much rather have something like marine ply, 8-10 mil thick, solid timber, than have a big chunk of foam sitting on the outside of my house. Because for me, I could easily just put a hole through the foam. It'd be pretty good effort trying to get a hole through that timber. So it's getting very, very safe. Here's a weird one. This is a bit of an architectural design, but it's incorporated a variety of different materials. So here we've got natural timbers mixed in with rustable steel and also things like copper. So varieties of different materials can be used on the outside. Fibro cement. We've talked a little bit about that. Fibrous cement sheeting affixed to the framework of the building. It's made out of cellulose fibre. We used to use, and this time we've got to be very careful because fibrous cement or fibrous cement, we had a couple of varieties of that. The old variety used to use a material called asbestos as a binding agent, asbestos fibres. The asbestos is a natural material, it's just milled and mined. When we incorporate it into a structure, it's generally sound while it's in the structure. However, once we go and change the structure or break the board or we tear it apart, it can release the fibres and the fibres they float in the air. And there's been a considerable number of people who have died from a thing called asbestosis, which is asbestos fibres getting into your lungs. Once they go into your lungs, they stay there. And therefore, once they're in there, the body then determines that's something that shouldn't be there, and it starts to attack it. And in doing so, over a period of time, that product something ultimately sort of changes consistency and ends up becoming cancerous. So people die from it, which is really sad. But it's an industry we've changed. But there is still a lot of this material out in the industry. Anything sort of 1960s and earlier, you've got to be very careful with our housing because the chances are you'll probably find that there's asbestos in the materials in the house, and you have to be very careful about removing that material. So it has to be specially removed by professionals who wrap it all up in plastic and wet it as they're using it to stop the fibres spraying up. And all right, here's another type of panel. It's foam, but it's a hybrid foam. So we're going to, remember I sort of talked about plywood, like marine ply, and I talked about foam. Well, let's put the two together, and we'll create what they call a structural panel. So what we're looking at now is foam injected into a mould. So you start out with usually two composite materials. You can use foam and various other materials. So we've got plywood sheeting. You could have fibrous cement sheeting. You can have any type of material you want, so long as it acts like a mould. So it's got the outside surfacing. And then inside of that, they inject into that area the foam. And the foam fills up all the airspace in between. And once it's all finished, it becomes a fibrous panel, a structural panel. It has excellent insulative property, and it's very good from a buildability because it's lightweight but relatively strong. Whole structures and houses are being built from these panels now, and it's just one version. There's other versions of it where they work in reverse. The actual foam becomes the panel, so it becomes the formwork, and then they'll do it like a block. So you'll have a foam block with hollow centre, of which you run steel bars through, and that hollow centre you fill up with concrete. So you end up with a concrete interior with a foam exterior. Most likely they're used on either walls or roof, so we need a base to start with, and then we can apply whatever cladding we want on the outside of that. Here's an example. I'll just show you this one by way of a guide as to what can happen in terms of speed. Now these are structural panels. This is a building that was under construction, so all the base is done. What we see here around the perimeter are channels, little U-shaped channels that are put into or screwed down onto the base. So it can be onto a timber base or it can be onto a concrete base. So all it is a receiving channel, U-shaped. You then get the structural panel, which is one big sheet, pick it up, drop it into that receiving panel, screw it in at the base, and once you've got a 3 or 4 panels together, you get the same type of U-channel at the top, drop it over the top of all the panels, and that then holds them all into place. So this is Monday. By Tuesday, pretty much all the ground floor is completed, and some construction on the top floor has been completed. By Thursday, the whole of the upstairs is finished, the roof is on, all made out of the same material. And by Friday, the weatherproofing, the waterproofing material, that's all this green, the waterproofing material has been applied over the top of all that material. So they're structural insulated panels. So we see the panels themselves sitting around the building. Outside of that is a waterproofing layer, then you put some form of external cladding as we would normally around the outside perimeter of the building. So that's just another way of applying some structure. What I'm trying to emphasize to you is there's no single way to build a house. There's a multitude of solutions. You can provide a multitude of different claddings, multitude of different materials, so long as the end result is the same. You're trying to waterproof the building and the interior framing. If you've got a material that may be susceptible to moisture, you put a skin of waterproofing on the outside of it, and that'll stop it from ever having any issue. Okay, finishing up, sarking waterproofing. For those of you doing timber cladding, you might want to have a look at this area because this is a requirement. So these are those timber boards that you would be looking at. There's the structural frame. Here's the interior lining with the plasterboard. In between the timber boards and the framing, you need to have some waterproofing layer incorporated into the building. And if you do that, it's going to give you two benefits. First of all, it's going to stop moisture getting in. The second thing it's going to do is going to stop air getting in. The other thing you don't really want in that sort of build is to have air coming in through your building too much. You want some air, but not a huge amount. Otherwise, high humidity, high moisture areas, environments, you allow a lot of moisture coming in. One thing we have is what they call vapor permeable. On the roof, I mentioned a thing called sarking. Sarking is waterproof. So it's aluminium and paper bonded together. So the aluminium and the paper act as an insulative material, but also as a waterproofing agent. This material on the walls is similar, but not the same. It's vapor permeable. In other words, air can get through it. However, it stops most moisture coming through. So it's designed to stop moisture coming in, but it's not designed to completely stop all the air moving through. If you ever get to a building site and have a look, you'll notice that the roof type material you can't see through. There's no light comes through that material. If you look at the wall wrap, you'll see that you can see light through that. And that's specifically that way. Why? Because they've discovered overseas, and New Zealand is probably the best example, they have this problem in New Zealand called leaky building syndrome. And the leaky building syndrome is not because the building leaks from outside, it's because the building is so heavily waterproofed inside that the inside moisture can't get out. And think about internally where we get moisture in our house. Okay, you're cooking on the stove, steam, having a shower or a bath, running your laundry, putting your clothes in a dryer. You're adding a huge amount of moisture to the atmosphere. And if that moisture can't get out of your building, it stays in there. So walls, vapor permeable. Roofing, fully moisture resistant. Okay, so that's the discussion about where we get moisture. Some of this vapor will move outwards through the plaster wood and other permeable materials until it either goes out into the atmosphere via the wall, reaches an impermeable layer, okay, which is also why in our design, I'll talk to you later. Remember this word, weep holes, okay? Remember the word weep holes. We'll talk about that a little bit later on, but that's our way of allowing moisture out through a building. And or meets a surface which is going to condensate the material. Okay, so we finish up then with the flashing. Flashing goes around our joints as well. So anywhere where we're going to change direction of our timber, around a window, around a joint where two walls come together, there's always going to be a point there where the boards are going to meet and there's not going to be a perfect alignment. There's a chance that even if you do put some form of silicone or other material that's going to stop moisture coming in, that sometime in the future that's going to separate and moisture will get in. So behind that, you always want to make sure you've got some impermeable layer that will protect your site if the worst happens and the moisture gets in.